Hello everyone, we're discussing thermal expansion. Note down this question. It's a circular ring of radius r. Coefficient of thermal expansion of the material, this wire, its coefficient of thermal expansion is alpha. Temperature is increased by delta T. Find out change in the area occupied by the circular ring. Ring, coefficient of linear expansion alpha, temperature is raised by delta T, and because of that there will be change in the surface area. Find out change in the surface area. Let's see if you can answer this question. Only one person has answered this thing. Look here. What is the initial area of the ring occupied by the ring? Pi r square. Now once you increase the temperature, let's say this is the shape of the ring and its new radius is r plus delta r. This much is delta r. What is final area? Pi r plus delta r whole square. We need to find delta A, which is A final minus A initial. A final minus A initial. For this you need to have information of what? Delta R. What is the initial length of the ring? 2 pi r. And what is the final length of the ring? 2 pi r plus delta r. That's the final length. So this is the final length and we have been given alpha. Alpha tells us that L final is L initial 1 plus alpha delta T. I have already shown you this thing. Delta L upon L delta T is a constant which is coefficient of linear expansion, which is all L, which is alpha. What is delta L? L final minus L initial divided by delta T, it gives you what? Alpha. Now, this is L final, this is L initial, delta T is given, alpha is given. Using this, you can find the value of delta R. Once you have the value of delta R, put it here and you can find delta A. Now, we'll solve this question assuming that the change is very small. For small change, we can do something like this. Let's take r common. This is pi r square. Inside this is 1 plus delta r divided by r whole square. Take r common. When it comes out, it becomes r square. Over here it's delta r upon r. And now I've already told you something like this, that 1 plus x to the power n can be approximated with 1 plus nx, provided x is much smaller than 1. We are assuming that change in radius, length, all these changes are very small, and therefore this whole thing is nothing but pi r square 1 plus 2 delta r divided by r. Multiply 2 inside. Multiply 2 inside. So this is your A final. This is your A initial. When you subtract this term of pi r square and pi r square, they are gone, and you are left with pi r square 2 delta r divided by r. Pi r square 2 delta r upon r. 2 delta r upon r, which is 2 pi r multiplied by delta r. So the only thing left is now is to find delta r. This is L final minus L initial. What is delta L? You can directly use this delta L. L final minus L initial. 2 pi r cancel. This is 2 pi delta r. Subtract. So L final minus L initial is 2 pi delta r, and this 2 pi delta r, when you subtract this, divided by original length L, 2 pi r divided by delta t is alpha. 2 pi and 2 pi cancel. This gives us delta r as alpha into r multiplied by delta t. Put it over here and you get 2 pi r multiplied by delta r, alpha r delta t, alpha r delta t, that is 2 pi r square multiplied by alpha into delta t. This much is the change in area, which you can also write as A initial pi r square is what? A initial multiplied by 2 alpha delta t. Write down this. Now notice this shortcut method. Delta A upon A delta T is also a constant, which is called beta, coefficient of thermal expansion for surface area. we know that this beta is 2 alpha. This gives us delta A as what? A alpha 2 delta T. A alpha 2 delta T. A, which is the initial area, 2 alpha delta T. This process of approximation, which we did when we developed relationship between beta and alpha, can be directly used for something like this. If you are comfortable with both methods, the lengthier one and the one line shortcut method, then write down yours in the comment box. Put on this question. There are two rigid supports and between these two rigid supports we have a rod. Rod of length L, coefficient of linear expansion alpha, and Young modulus Y. What is Y? Young's modulus. These are two rigid supports. There is no way you can change separation between these two rigid supports. Length of the rod is L. Its cross-sectional area is A. Coefficient of linear expansion is alpha. Young's modulus is Y. Temperature is increased by delta T. If temperature is increased by delta T, then find out stress developed in the rod. When temperature is T, its length is L. But when you increase the temperature, you know that length is going to increase, but you cannot increase separation between these two rigid supports. So if you are trying to increase length of this, definitely stress will develop in the rod, longitudinal stress. So find out how much stress develops in the rod in terms of all the given quantities. Should not take more than 30-40 seconds. Let's see if you can answer this. Not many responses. But look here, the correct representation should be in this form. If you increase the temperature, delta L upon L delta T is alpha. It gives us what? Change in the length, delta L. So, what would happen to this rod if no rigid supports are present? Well, let's do one thing. Let's keep this rigid support here and remove this one. It will be easier for you to understand the whole thing. If you increase the temperature, rod will take this shape. This much is delta L. If this support is not present and you increase the temperature, that's how it will look. But now you're saying that you want to fit this rod back between these supports. For that, we can imagine as if somebody exerts a force in this direction, shown by this red arrow. So, this is the length of the rod when you have increased the temperature by delta T, and now you are pushing this end back inside so that it can easily fit between these two rigid supports. So, for this type of setup, you know that stress upon strain is what? Young's modulus. Stress upon strain is what? Young's modulus. So this is the Young's modulus. Then we are interested in finding F upon A. What is F upon A coming? Delta L divided by L multiplied by Young's modulus. What is delta L upon L? Alpha delta T. Alpha delta T multiplied by Young's modulus. That's the answer. Change in length divided by length is strain, and we have found value of strain using what? Coefficient of linear expansion, and then using stress upon strain, which is a constant called Young's modulus, we can easily find value of the stress. Note down this. Note down this. It's a bimetallic plate system. There are two strips of two different types of metals. Coefficient of linear expansion is alpha 1. Coefficient of linear expansion is alpha 2. And we have been given that alpha 1 is greater than alpha 2. Assume that there will be no change in this dimension, or you can say that as compared to length, length is L, as compared to length, width of these plates, strips, that's not comparable to length of the rod. And let's say this thickness is B, and this is also B, and we have been given that B is much smaller than L. Now, as temperature is increased, the entire system, can you tell me what will happen when I increase the temperature? Look at this. These two plates, they have been welded at the junction. They have been welded over here. It's a fixed joint, and then we are increasing the temperature. So the first question I'm asking you is what will be the shape of the whole thing once you increase the temperature? Just think about it, and then I'll ask you the next part of the question. These are two different metals having different linear expansion coefficients, alpha 1 and alpha 2. No response. Now tell me, the whole structure is rectangular initially. Will it remain rectangular afterwards? Answer this way. The final shape, will it remain rectangular? What do you think? Good. It will not remain rectangular. And if you have any experience of this type of thing in your life, I'm not talking about solving a question, I'm talking about something made up of two different materials and then you find that temperature increases, then you must have seen bulging over here or on this side. So the next question I'm going to ask you is the final shape of the whole thing. It will be of this type 1 or type 2. What do you think when you increase the temperature and this rectangle deforms, then how will it look? Type 1 or type 2? What do you think? Well, most of you have answered correctly. Look at this. Alpha 1 is greater than alpha 2. If alpha 1 is greater than alpha 2, then if you do not have this type of welded joint, if these two plates you separate them and increase the temperature, then that's how the system is going to look. The lengths are going to increase, but since alpha 1 is greater than alpha 2, ये जो फर्स्ट वाली रॉड है इसकी लेंथ ज्यादा इंक्रीज होगी. If there is no weld between these rods, then that's how the system is going to look. But question says they have been welded together. If they have been welded together, if you look at this system, then the lower plate has longer length as compared to the upper one. But this tells us that the upper plate should be longer, which is, you can see clear in the second profile. So, final shape will be this. Now comes the actual question. The question is, as it deforms, and if we assume that after deformation these plates take circular shapes, then find out theta. What is this theta which you are going to see? That's what the question is. Let's see if we can find the answer. We are assuming that these plates, they deform, and after deformation they take what? Circular shape. Look here. Well, everybody knows the formula for arc length. If this is r, this angle is theta, then arc length is r multiplied by theta, arc length. Now this is the arc length. Let's say this much is r. This is r. Let's find out mean length. You can see that this edge, the lower edge of the second plate, will be smaller as compared to the upper edge. So let's go for mean radius. Mean radius will be for this part. How much you need to add? B by 2. Similarly, when we go for mean radius of the upper plate, we'll be taking this. We'll add another B by 2. Of course, not in B by 2, but in B. The whole thickness is what? B. Now, instead of going for the lower edge or for the upper edge, we'll take the mean radius. What is the mean radius? R plus B by 2. So the second rod, its final length is for this one, final length L2, this length L2 is what? Radius multiplied by the angle. What is the radius? R plus B by 2. R plus B by 2 multiplied by theta. This is the final length, which is equal to what? Initial length, which is L, 1 plus alpha delta t. We have found the L2 part for the second plate. Similarly, we can find L1, final length of the upper plate. Let that be L1. What is the radius of the upper plate? R plus B plus B by 2. R, then add this thickness B and then the average B by 2. Original length is what? L, 1 plus alpha 1 delta t multiply by theta also. For both circular arcs, your theta is what? Same. Done. There are two unknowns, r and theta. There are two equations. Solve these equations and you get your answer. From this one, first do what? Divide. You can find the radius also. Once you find the radius, put it here and you can find what? Theta. Are you comfortable with this approach, yes or no? Tell me first. Do you understand this?